This is IAT806 Lecture 2.2, and in this segment we will talk about the processing setup and draw functions. And these are two functions that you use in most processing programs, just about every processing program except the simple scripting things that I've shown you earlier, use setup and draw to get things going. The last thing we'll talk about in this segment is time, functions, methods that you can use to measure time in processing programs. Okay, so let's get started. The first thing that I'd like to talk about is the setup function. Now, a setup is a name that processing is looking for when you program it inside the processing window. And the way it works is that setup is a predefined processing method that processing knows about, as it were, that you define. And as the little bubble there says, the syntax of it is in fact void setup. We'll talk about void in the next slide, but for the time being, let's just accept that it is entitled void setup, open and close parenthesis. So that's the syntax of it. And the way it works, I'll show you a little bit further as we move forward. The ways what setup does is it is called once when a sketch or a processing program first starts executing. And that is the semantics of setup. It's called once at the beginning, one time only. And basically the idea of using setup is that you will use it to do things like setting up the size of the drawing window, which we have not yet done. We've just simply used the default drawing window size, and we'll show you that shortly. Setting the background color, although that's also valuable to do in draw, which is the next method I will talk about, and most importantly, initializing variables for the first time. In Java, you are required to initialize all variables before you start using them for anything, and so setup's a good place to do that, to create the variables that you need throughout the program and put them in initial values that you need for the program. And so that last thing, remember I spoke of earlier in a previous lecture set about syntax, semantics, and design. Well, here it is. The syntax is void setup, and I'll show you more in a bit. Setup, the semantics are setup is called once when the sketch first starts executing, and the way you use it, the design aspect of this, is you set the size of the drawing area, initialize the color, initialize variables, and so forth. Now, I mentioned the word void. I hadn't spoken of it yet. What is void? Well, void is a Java name that is a special empty type, and it is used for setting things like the return type of methods. And so what setup is, syntactically, is a method, and declaring a method looks like this. So the first thing you do with a method is say what kind of values that method returns. Setup in this case is the method name. You know we're defining a method because it has an open and close parenthesis, and the initial type statement here in this case is void. What does that mean? It means that setup, the method that's being defined here, doesn't return any type at all. It just simply does its thing and returns without giving a value back to the caller. So void setup means that the setup method does not return anything. Compare this to something like cosine, which I'm just giving you a basic sketch of here, a little indication. You could imagine that the cosine function, abbreviated as cos in the math library of Java, it returns a floating point value, a real number. And what it takes as a method is a single value theta, which is the number of degrees or whatever it is, number of radians actually, of the angle that you want to compute the cosine for. So cos computes the cosine of the angle theta and returns that cosine value. And so that means that for cosine, you need to have a float return type because it gives you a real number, a floating point number. Setup doesn't need to return anything, so that's why we've set it as the void return type, which is what the processing system specifies. Okay, now we've spoken briefly about setup. Let's now move on to draw. Like setup, draw is another method that you define. It's predefined within the processing system, and you define what it actually does. And like setup, it returns nothing, so it's got the void return type. So draw is a predefined processing method that you define, and the semantics of draw is that draw is called automatically and repeatedly by the processing system, typically around 30 times per second, but not always. You put in the draw body, as it were, the stuff that you need to constantly update in the display. For example, when you would wish to animate an object. So if you want to do some something interactive, basically what you need to do is to create a draw method and put your interactive behaviors inside the draw body of the draw function. So here's an example. I wanted to put an example where I showed both setup and draw together. So here it is. And so it's a very simple example. So the first thing that happens in this program is we declare an integer x and y as integer variables. And we'll see, I'll show you in a bit why it is we declare these here as opposed to anywhere else. Next is void setup, and the colors I'm using are set by me on this slide. You get a different set of colors inside the processing system. Void, I'm just meaning that to indicate that this is the special empty return type. And you don't, the way you use it is you say void setup, open and close parenthesis without anything in there, and then open brace and close brace. And so everything between the left brace and the right brace is going to be executed once at the start of the program. And the first thing that we do here is we say size 400 to 400. And what that is doing is calling processing's size function, a size method, and it is setting the size of the drawing window to be 400 by 400 pixels. The next thing is that we call background with 0. And what that means is we clear the drawing area to be all this color. The color is 0, and that means black. All the RGB values are equal to 0. And we set this x value to be 0 and y to be height over 2. Now height is highlighted in red here because height is a special processing variable that is set to be the height of the drawing area, which we know is 400, but as soon as you set the size, it fills in the value of height automatically. And we're dividing that by 2, so it's in the middle of the vertical extent of the drawing area. And anyway, that's the end of the setup function. Now let's look at the draw function. So this says void draw, and again, open and close brace. And that means that, once again, draw returns nothing, so it's got the void return type. And draw is called repeatedly by the processing program until the program is stopped. So every time the draw function, the draw method is called that we've set up here, it, once again, clears the screen to be black with the background 0 call. And then it draws an ellipse using the x and y values and size 20 by 20, so it's drawing a 20 by 20 circle. And then it adds 1 to x by saying x equals x to 1 plus 1, and then if x is greater than width, which it sets x to 0. And width is another one of these special variables that processing has. Width and height are both to do with the size of the drawing area. Width is the width of the drawing area, which is 400. Height is the height of the drawing area, which is also 400. So when the value x exceeds the width, it sets x to 0. So what I'd like you to do now is to think about what it is that we're going to get when we run this program. So I'll just wait 5 seconds as you think about it. Okay, so here we're showing the processing programming area. And once again, with int x, int y, void setup, the spacing's a little bit different, but it's pretty much the same thing. We set size to be 400, 400, background to be 0, x equals 0, and y equals height over 2. So that's executed first. And then the draw function clears the background, draws the ellipse, adds 1 to x, and if x is greater than width, sets x to 0. So let's run that. So here is the drawing area. As you can see, it's somewhat larger. Previously, I had shown the drawing area, had the drawing area be 100 by 100, but in this case, now that it's 400 by 400, I haven't scaled it up so much. And so things are, fit within the video area that we can see. And as you can see, what's happening is that this white circle is moving to the right, and then once x is equal to greater than width, or 400, it sets x back to 0, and the circle jumps from there to there on the next frame. So this thing will keep running until you stop it. And the reason why, of course, is because over here in the program, we have this draw function, which is called repeatedly 30 times a second, automatically called by the processing system to clear the screen, draw the ellipse, increment the x value. Now, the reason why this thing works is that it is using two variables, x and y, that are declared out here. And what that means is that these two variables are available to all the code that follows. And what that means is that the scope, this is a technical term, the scope of these x and y variables is the entire program, because it is not declared within a pair of braces. Okay, so one of the things to bear in mind is that setup and draw are both examples of what are called callbacks. A callback function is defined by the programmer, as we have defined here in the little code segment I just showed. And it is defined by the programmer, and a callback gets called in response to some internal event to the system. In this case, what the internal event is internal to processing. The internal event is a startup when processing starts running a particular program. It, so to speak, looks for setup and calls it once automatically at startup time. Also, to call draw, processing automatically calls draw 30 times per second or some other rate that you can set. So the processing system is responding to an internal event that goes off 30 times per second, and in response to each one of those things, calls draw automatically. So the callback gets called in response to the internal startup event of processing that's runs setup, and draw is called automatically 30 times per second when an internal timer to processing goes off. You, as the programmer, don't usually call callback functions directly with your own code. You'll notice in the code example, there is no call to setup or call to draw in the little piece of code that we showed you. Setup and draw are predefined within processing as to be called if defined, as it were. Now, I spoke about the rate at which draw is called by the processing system. You can control that, but you do control it indirectly by making calls to other functions. Typically, you would do some of this stuff within the setup method to control, for example, framerate. So framerate can be used to set the number of times per second that draw is called automatically. And so if we were to put framerate 30, what that means is that draw will be called 30 times per second if the computer is capable of doing so, which most computers are. However, if you wanted to, for some reason, delay the execution of calling draw, you can issue the delay calls. And if you want to do this, you would do this typically within the draw method. And so delays execution for a certain number of milliseconds. So delay 250 delays for 250 milliseconds, which is a quarter of a second. You can use delay or frame rate to determine how fast you want draw to be called, but probably the best thing to do is to figure out how often you want draw to be called automatically and then issue a frame rate call with that number. These last two things here seem a little puzzling, but they'll become more clear in the next slide set. But I wanted to put all the draw control stuff here on a single slide so you can find it when you need to. Anyway, the first of these is something called no loop. And what that does is it tells the system to stop automatically calling draw if you want to, for example, turn off animation. So inside the draw function, you would say have an if statement, if some condition, and then within the body of the if statement, put a call to no loop without any arguments. It has an opposite call called loop. And what that does is it tells the system to start calling draw automatically again. and you would use no loop and loop together to turn automatic draw calling on and off. Now, if you were to put a no loop within the draw method as we have it right now, there's no way that you could turn automatic draw calling on again, because there's no automatically called method to execute a loop call. But we'll see how that can be done later on. So at the moment, just recognize that loop and no loop are things that you could use if you wish to. So we had just finished talking about how to control how frequently draw is called, and talked briefly about some other control mechanisms. Here, what we're showing is a number of calls that you can make to processing functions that tell you the current real time according to the computer's clock. So the first one listed here is hour. Let's say you had a variable named h, int h equals hour, open close parentheses. That will tell you the current hour at the moment at which the hour function was called. And the hour function returns the value 0 through 23, where 23 corresponds to 11 p.m. at the moment it was called. Minute will tell you the current minute from 0 to 59. Second will return the current seconds from 0 to 59. Day will return the current day of the month from 0 to 31. Month returns the current month as a number from 1 to 12. And year will return the current year, say 2020. Each of these calls tells you the time that was measured at the moment that the call was made. So if you were to call things in a funny order, then don't be surprised if you get a little bit of skew between one thing and another. So all of these things tell you what the current computer clock thinks the time is. Milliseconds, instead of telling you what the time is, tells you the amount of milliseconds that have passed since you started this particular run of the application. So if you stopped your program and started it again, the first time you called millis in your program, you would probably get a low number, because it's measuring the start of the program, not the real time, not the current time as it is at its current time of day. So these 6 calls here are about time of day. This thing is about the amount of time that your program has run in real time. So draw is also controlled in some sense by a timer, typically set through the frameRate call. However, the value returned by second or millis has nothing to do with how often draw is called. Calls to draw are triggered automatically by an internal timer, but you cannot then turn around and attempt to use draw as a proxy for measuring the amount of real time the previous or next draw call took. Instead, what draw is doing is it's just simply, if you were to count the number of times draw was called, you really would just be measuring the number of frames or the number of instances of draw. In particular, you don't necessarily know if each draw, in fact, took 1/30 of a second, if indeed you set the frame rate to be 30. So to test this, you could put println in a loop to see how often it gets called. And what you would be interested to notice is that with this tiny little draw function here, you end up with kind of an interesting variance in the values that you get for the number of milliseconds that have passed since the previous call. So the way in which this thing works is we set up a variable named last time loop was called, initialize that to 0, and then within the draw function, we call millis, assign that to the milliseconds value, and then take the difference between milliseconds and the last time it was called. We print that difference out, and then set the last time loop was called to be the current value of milliseconds. And then draw, that's the end of draw, and then when next time draw is called, automatically we do it again. So let's just show what that looks like inside the processing function. So here it is. I've got the same setup as before, just this stuff here, although we're not really going to do anything with that. Our intent here is to just simply measure how frequently and what kind of time you're going to get from this last time loop was called. So let me expand the size of this, stop it, and restart it. So after it's started up and I've scrolled to the top, I've cut out the, sort of waiting for it to start printing stuff out. And you can see that the first value it prints is 428. And what that means is that it took 428 milliseconds for the program to go through its setup process and to call draw for the first time. And then you see subsequent values, 17, 16, 16, 18, 17, 18, 16, 18. You can see that there's a reasonable amount of variance from one call to the next. And what that means is that although in this case, a draw is being called automatically 60 times per second, it's internally but defaults to a frame rate of 60, it is not an identical runtime every single run. And in fact, you see a 2 millisecond difference, which is certainly not very large, but it's enough that of a difference from frame to frame that if you were attempting to measure the real time that is passed by counting draw calls, you'd be disappointed at the noisiness and the variance of the values that you get. Okay, so that's it for this segment about setup and draw and time, and we'll end the video there.